Okay, so welcome to week two. So this is our week two video. I've enjoyed looking at the discussions. I will say I'm a little bit surprised. I think this is maybe the fourth time that I've taught this class, and typically people really like um, the Paul Halmos essay, which is why I keep coming back to it. But it seems that this time we might have slightly more critical or negative opinions of it. So I'm looking forward to how that's going to play out as we go on. Um, I will just say that if you don't like it, then you're wrong. No, I'm kidding. Paul Halmos is basically universally recognized as one of the best writers, one of the best expositors of mathematics. Hold on a second. Sorry, there was a cart rolling by. So, anyways, he is recognized as one of the best expositors of math. So this is one of the reasons that I have this because he's really good at it. So I'm going to give you one of my favorite books, one of my favorite math books here, I guess I should say. It's called Finite Dimensional Vector Spaces, and it's written by Paul Halmos. So this book is it's a course. So finite dimensional vector spaces, we're essentially dealing then with linear algebra. There's kind of two ways you can think through linear algebra. One way, when you think through linear algebra, you really focus on systems of equations and matrices and things like that. You can also sort of teach linear algebra and have a very sort of operator theoretic and what we'd call functional analysis point of view, just done in finite dimensions. He takes that second approach. So this is sort of linear algebra written from one perspective. And even though I personally prefer the first perspective, where you emphasize more matrices and things like that, it's still a very good book if you want to discuss abstract linear algebra or abstract vector spaces. Okay, at any rate, so for this week we are going to be doing program control, NumPy, SymPy, and Matplotlib. So what we're going to be doing then, program control, there are some comments in the discussions. This is when we look at for loops, if-then statements, or if-else statements, that sort of thing. There's no then, but if statements, things like that. NumPy is a package which lets you do a bunch, or has a, there's a bunch of functions in there to do numerical computations. SymPy is a package where you can do a bunch of symbolic computations. And then Matplotlib is a package where you can plot things. This is very similar to MATLAB's plotting, which I think is probably why it's called Matplotlib. On the assignment, the goal for what we're going to be doing on the assignment is we are going to be writing a function to numerically differentiate a function, numerically integrate a function. So like doing difference quotients for the derivative, doing very simple Riemann rectangles for the numerical integration. Not going to get fancy. Then we're going to use SymPy to do symbolic differentiation and symbolic integration of those functions. And then we're going to use Matplotlib to maybe plot something. I haven't exactly decided how that's going to fit in there yet, but it's going to fit in there somehow. So those are going to be the three things that we're going to do this week. And I hope you like it.